All right, for this next video, we're going to look at the connection between angles, either inside or outside of a circle, and the arcs formed. So just like with segments, we have two formulas, pop, pop, for when the lines cross inside the circle, and ow, ow, when they cross outside the circle, like this one. Again, we have two different formulas, but this time we're going to be looking at angles and arcs. So if the lines cross inside the circle, the angle is inside the circle, and we have the formula angle inside equals 1/2 of the two arcs added together. So that is what we use for number 12 and number 23. Let's do those one at a time. For number 12, we have here the angle is 55 and our arcs are x and 70. So 55 equals 1/2 x plus 70. We just fill in what we know into this formula. All right, the easiest way to get rid of this 1/2 is to multiply both sides by 2. 55 times 2 is 110. And then when we multiply 1/2 by 2, that all cancels out. So we have 110 equals x plus 70. So then all I have to do is subtract 70 from both sides. And that gives me x equals 40 degrees. So this arc is 40 degrees. And you can always double check it by just checking this formula. So 40 plus 70 is 110. Half of that is 55, so it works. Okay, let's try that one more time with number 23 off the same review. So in this case, we have that the arc AC is 26 degrees. We don't know the angle, that's what we're looking for. Actually, we're looking for AXC, which is this side, but these two are vertical angles, so they will be equal. And then this arc, DB, is 84. In this case, we don't even have to solve. We're just plugging in, and the formula is already solved for angle, which is what we're looking for here. So the angle is equal to 1/2, and then our two arcs, 26 degrees plus 84 degrees. I left the little degree mark off. Okay. 26 plus 84 is actually 110. It's the same as what we had before. So this is 1/2 of 110 degrees, which means that angle is 55 degrees. Of course, that's just a coincidence that we had an angle of 55 in both of those problems. It could be anything. All right, so that's a couple of examples of what happens when the angle is inside. Now let's look at what happens when it's outside. It's the same setup, but when the angle is outside, you're always going to have one arc bigger than the other. So what you're going to do on this is you're going to actually subtract them. Instead of adding, now we have subtraction. Big minus small times 1/2 gives us the angle. So let's take a look at number 13 for that. Again, you have to think about what you know. So this 40, that's our angle. Y is the small arc, and 124 is the big arc. Okay, so plugging into this formula, I have 40 degrees is my angle, equals 1/2. Big arc is 124 minus y. All right, to get rid of the 1/2, I'm going to multiply both sides by 2. So it's going to give me 80 equals 124 minus y. I can subtract 124 from both sides. That will give me a negative number, but that's okay because I have a minus y here. 80 minus 124 gives me negative 44 equals, and this is a negative y. So in order to solve for y, this is -1 times y. So I can basically just divide both sides by -1. which is just going to get rid of both negatives. So y is equal to 44 degrees. And of course, you can always double check it. If y is 44, plugging back into the formula, 124 minus 44 gives me 80. And I take half of that to get the angle, which is 40, which works. All right. And last problem like this is number 22. This time we have the two arcs. We have the big arc is 108. The small arc is 20. And we're looking to get the angle. TXE, that's this angle right here. So the angle is equal to 1/2. Big arc is 108 degrees minus the small arc is 20 degrees. That's going to give me 1/2 of 88 degrees, which is 44 degrees. So this angle is 44 degrees.